Welcome back to Saxon Math. This is lesson 21 out of course 1, divisibility. Let's get right into it. The new concept. There are ways of discovering whether some numbers are factors of other numbers without actually dividing. For instance, even numbers can be divided by 2. Therefore, 2 is a factor of every even counting number. Since even numbers are able to be divided by 2, we say that even numbers are divisible by 2. So there are tests for divisibility. They can help us find the factors of a number. Here we list the divisibility tests for the numbers 2, 3, 5, 9, and 10. So you can see that if you inspect the last digit of the number, a number will be divisible by 2 if the last digit is even. So that would be 2, 4, 6, 8, 10, 12, 14, 16, and on and on and on. Any even number that has the number that ends in it. So let's go on to say like 358 or 88. 388 is an even number because that last digit is even. It's either a 2, a 4, a 6, an 8, or a 0. It's divisible by 5 if you look at the last digit being 0 or 5. So any numbers that end in 0 or 5, 5, 10, 15, 20, 25, 30, any of those numbers you notice they end in either 5 or 0, 5 or 0, 5 or 0, and it could go on to infinity in that case. And if, let's say, we've got 850 ends in a 0, that's also divisible by 5. It's also divisible by 10 if it ends in 0. So 10, 20, 30, all those numbers end in 0, so they're divisible by 10. And it would go on to infinity, so it could be any number. 1070 or 870 would be divisible by 10. You can also use the sum of digits test to test for divisibility of 3 by 3 or 9. So in these cases, in this instance here, if you want to check to see if it's divisible by 3, you can add the digits to find out. So let's just use 12. Everybody knows that 12 divided by 3 works, but if you were to add the two digits together, the sum of those digits, if we took 1 plus 2, that equals 3. 3 is divisible by 3. But let's say you have a bigger number. Let's say it's 120, let me see, 23. 123, if I was to add these up, if I took 1 plus 2 plus 3, if I was to add those up, it equals 6. And 6 is divisible by 3. I know that 6 divided by 3 equals 2. That means that this number 123 is divisible by 3 before I even go ahead and do that. So if I have 123, you don't know for sure if it's divisible by 3 just because it doesn't have anything to do with the ending with 3, but let's look at it. 12 divided by 3, I knew 1 divided by 3 doesn't work. 12 divided by 3 is 4, so that'd be 12. Subtract that, that'd be 0. Bring this 3 down. 3 divided by 3 is 1, and then that'd be 3. There'd be nothing left over, so there's nothing there. 41 times 3 is 123. So 123 is divisible by 3. You can also do the same thing if the digits are divisible by 9. So if you're looking at this 9, if the sum of the digits is divisible by 9. So if we're trying to look at, is 123 divisible by 9, 123, if you add up each one of those pieces, it doesn't work out because 6 divided by 9 does not work out to be a nice even number. It will work, but it's a fraction, so it doesn't have a nice even number like this one did. 123 divided by 3 worked out to be 41. So it'd have to be something that's divisible by 9. So like 1 and 8, for example. If you add 1 plus 8, that equals 9, and 9 divided by 9 equals 1. So that means that 18 is divisible by 9. If we had another one, say, even if it's 180, let's say 180, those add up to 9. If you were to add up each one of those, you got 1 plus 8 plus 0, that equals 9 as well. 9 divided by 9, again, is 1. So that means 180 is divisible by 9. And you'll see that if you do the math and you bring it down, you get that. This would be 0, so 20. Okay, so using those divisibility tests, you can test before you actually do the long division. So for example, which of these numbers is divisible by 2? So let's just look at what do you have to do to know what's divisible by 2? To find the divisibility of 2, it just has to be the last digit has to be even. So if I'm looking for divisibility by 2, the last digit, well, this one's odd, this one's odd, this one's even. That's it. This one ends with a 6. 6 is even. Which of these numbers is divisible by 3? Remember, you have to be able to find the divisibility. Instead of doing the math all the way out, it'll actually be easier to take 3 plus 6 plus 5 to find out if that's divisible. So what's that? That's 14. Is 14 divisible by 3 without a remainder? If I do 14 divided by 3, that's the same as, let's see, 4 will get me to 12, and there's a remainder. The remainder 2 would be 4 remainder 2. So this one is not divisible by 3. Let's look at this one. If you have 1 plus 1 plus 7 plus 9, that's 18. 18, if that's divisible by 3, then yes, this 1,179 is also divisible by 3. And 18 divided by 3 is 6. So that means that 1,179 is also divisible by 3. It'll work. And let me just do that real quick here. So if you've got 3 will go into 11, it'll go in there 3 times, that'll be 9. Subtract that, that'd be 2, so it would be 27. 27 divided by that would be 9. 9 times 3 is 27, there'd be nothing left over, and then 9 divided by 3 is 3. So 393, this one is divisible by 3. Let's make sure this one is not or is. Let's look at it. We'd have to have 1 plus 5 plus 5 plus 6. This would be 6. 12 plus 5 more makes 17. Is 17 divisible by 3 without a remainder? Well, 17 divided by 3 is the same as 6, would get us to 18. That's not going to work, so I need to go down to 5. So that'd be 15. Subtract that, that'd be 2 remainder. So there's no, this does not work either. So this is the only one that's divisible by 3. And we didn't have to go through all this mess. All we had to do was look at the numbers. What do they add up to? It adds up to, in this case, it adds up to 18. And 18 I know is divisible by 3, so the answer is yes. I don't even have to go through all the hubbub of actually doing the division in that case. Let's look at another one. Which of the numbers 2, 3, 5, 9, and 10 are factors of 135? So let's check it for divisibility. Those factors mean that's what it's divisible by. If it's a factor, that means 135 can be divided by 2. Well, 135 is not divisible by 2 because it ends in a 5, so it's not even even. Now I need to check for the divisibility of 3. So the sum is divisible by 3 if I'm looking at 3 for the test. So let's see if that works. So the sum is 1 plus 3 plus 5, sum of the digits. So 1 plus 3 plus 5, that equals 9. 9 is divisible by 3, therefore 3 is one of them. 5. 5 would work because it ends in a 5. Remember the test for the divisibility of 5 is 0 or 5. 9. Do these, the sum of those digits, are they divisible by 9? Well, the sum is 9, and yes, you can take 9 divided by 9, that equals 1. So that means yes, 9 is also something you can divide it by. And then 10, what's the test for 10? Well, it has to end in a 0, and that's not for 135. So the numbers 3, 5, and 9 are factors of 135. And if I wanted to double check all that, if I wanted to say, oh, I don't know for sure, I'm a little hesitant, you just have to do the division then. So 5 will go into 13 two times. Subtract that, it'd be 3, bring that down. 35 divided by 5 would be 7. 35, there'd be nothing left over. That is divisible. I could test the other two, but I won't. But yeah, you could do that. So let's try that. Which of these numbers is divisible by 2? Go ahead and answer that. All right, for this one, you would notice, hopefully right off the bat, this is the only one that ends in an even number. So 234. The check for is if it's divisible by 2 is it has to be an even number. This is an odd number, this is an odd number. Letter B, which of these numbers is divisible by 3? So in order to test for the divisibility of 3, I have to add up the digits. So 1 plus 2 is 3, plus 3 more is 6, plus 4 is 10. 10 is divisible by 3. It is not. It's not going to get me an answer without a remainder. This one would be 2 plus 3, that's 5, plus 5 more is 10, plus 4 makes 14. If 14 is divisible by 3, then yes, you can divide 2,345 by 3. The sum of these digits is 7 plus 5 makes 12, plus 6 more makes 18. This one's 18 divided by 3, and that would be 6 even. So yes, this is divisible by 3. This one is not divisible by 3, neither is this one, because this would end up being a remainder. This would be like 3 remainder 1, right? This would end up being 4 remainder 2. If you did the math on this one, it'd be 4 remainder 2. Use the divisibility test to decide which of the numbers 2, 3, 5, 9, and 10 are factors of the following numbers. So letter C. Go ahead and do that. Let me share this with you guys. So when you do that, so using the divisibility test for 2, is it divisible by 2? Well, give me the list. Is it going to be 2, 3, 5, 9, or 10, or all of them, or some of them? So answer that now. All right, and if you answered 2, you got that correct in this case because it's an even number. 3 also works because 1 plus 2 is 3. 3 is divisible by 3. 5 also works because it ends in a 5 or a 0. It ends in 0. 9 does not work because for the divisibility test for 9, it has to be divisible by 9. And 3 does not divide into 9 evenly. It would end up being a fraction. It'd be 1/3. So that means 9 doesn't work for this one. And 10 does work because it ends in 0. So this would be the list. You'd have 2, 3, 5, and 10. Go ahead and do letter D. List of all these numbers, 2, 3, 5, 9, and 10, which are divisible without actually dividing it. This is not, the goal is to not actually divide these numbers, but to use the tests. So you're testing it. If it's divisible by 2 if the last digit's even, it's divisible by 5 if the last digit is 0 or 5. It's divisible by 10 if the last digit is 0. It's divisible by 3 if the sum of the digits is divisible by 3. And it's divisible by 9 if the sum of the digits is divisible by 9. So go ahead and use those tests to determine if 102 is divisible by any of those numbers. right? The first one you should right off the bat, there isn't much of a test to it. It's just even or odd, right? If you know what an even number is, then you know it's divisible by 2. So yes, it is divisible by 2. It ends in a 2. Looking at the second test, or the second number. Second number is 3, and 3, the test is if the sum of the digits is divisible by 3, then the number itself is divisible by 3, and 1 plus 0 plus 2 makes 3, so that means 3 is divisible. 5, to test for 5, it has to end in 0 or 5, so that means this does not, it ends in a 2. 9, again, the sum of the digits is 3, and that is not divisible by that. And then 10 has to end with a 0, and it does not. So this is our list. It's a short one. 2 and 3 would be the answer for that one. All right, excellent work. Make sure you guys do your written practice during school, and we'll see you next time. Thanks for watching all the way through with your eyes and your ears. Have a great day.